Okay. We've still got a minute or so. But can get ready to begin at least. Happy Thursday. I guess that's what this is. End of the week. Let's go ahead and jump in. Couple of reminders for today, just because of questions that I've had over the last couple of days. If you want to see class recordings, you can go to the Start Here button. And underneath the module for the given week, or for the given test rather, I always post recordings from class. So we've had 3 classes so far. So that's where you can find the recordings for all of our classes under the test 1 module. And then more will come as we progress in our class. There is another option for viewing recordings. Ooh, I need to sneeze, excuse me. You can go to the up to test 1 schedule and lecture notes. Click on that. And then at the very bottom of this page, there are lectures from previous semesters. The one at the top, that's current, essentially. So that'll have the same slides that we are using for our class. We'll go through the material in the same order. The ones on bottom, they won't necessarily go through things in the same order, but they are kind of nice because they're broken down into little snippets. So little, I think 6-minute videos, I think is approximately the length of each video. So it's a little bit easier to find your way around and figure out which problem you're looking for. So any of those are options for you as you are looking at material for our course, if you want to fill in some gaps that may be things that you missed during class. Okay. One other thing that I will mention is that last time there was a request for a problem similar to the one that we did at the end of class last time. So essentially the one that we did outside of class, that I said you could go look at the videos for if you wanted to not stay after class. I looked at the quiz for this week and you don't have a problem like that on your quiz. It was on there was one like that on a different quiz. So I was thinking that there was one on this week's or next week's quiz, but there is not. So here's what I'm going to do. I am going to wait on giving another example similar to the one we did end of class last time. If you want to see another example, happy to do it at the end of class if we have time or after class. But because we have a longer lesson today, I don't want to do another example on something that you won't see on the quiz. I think what we're talking about today will take up the entirety of the time that we have. So just as a heads up, that is the plan for today. Any questions that you have before we start with today's lesson? All right. Sounds good. We are on lesson 3. Last time we talked about conversions in the metric system. Today we are going to talk about conversions in the customary system. You can also do conversions between systems. We want to be able to begin with linear distance conversions, but also move to weight conversions in that system as well. When we converted between units in the metric system, you can recall last time that that was a simple matter of remembering the prefixes and moving the decimal point either to the left or to the right based on the number of prefixes that we moved. When we do conversions in the customary system, however, the process is a little bit more complex. It's not, it's not rocket science, but we do have to think a little bit harder to convert in the customary system. The process basically involves two things. We'll start by finding a conversion factor or relationship between units. And then we will decide, do we want to multiply or do we want to divide by the numbers involved in that conversion factor? For our purposes, we're going to do a lot with the conversion chart that you can find on Canvas. At the very top of the test one, excuse me, we're not in test 2 yet, test 1 module. So this conversion chart is something that we're going to use a whole lot. So I recommend that you print that and just have it handy. I'll bring it up whenever I do a problem. I'll try to refer to it and bring it up, but it will be helpful for you to have your own copy of that. So I definitely recommend that you print that at some point before our next class. Okay. So let's begin some conversions. That means I have to share from my other device. All the tech takes a minute. Okay. So as a reminder, linear units are units that measure distance. We've talked about some customary linear units, and those are inches, feet, yards, etc. You're familiar with miles, you're familiar with a lot of others. The conversion chart that I refer to will have some conversion factors, many of which are listed here. Customary units of linear measure, as mentioned, involve these 4 units as well as others. And we know from experience that certain units in the customary system are equal to a certain number of units of another type of units also in the customary system. Many of these you're familiar with, some of them you are not. To get a conversion factor, we're going to look at one of these equivalences, say 1 foot and 12 inches. Or we could go with 1 yard and 3 feet. We could pick one of these equivalences, just depending on what we're wanting to convert to. And then we are going to decide, do we want to multiply by, say, the 12, or do we want to divide by that 12? Do we want to multiply by the 3, or do we want to divide by 3? And that's the basic process. You don't need to memorize this conversion chart. As mentioned, it's a good idea to print it, to have it handy. It will also always be provided for you on tests or quizzes in which you need it. So work on learning how to use it. Don't work on memorizing the conversions themselves. I should probably point out a couple of these that are maybe less familiar. We don't use rods a whole lot. They're used in agriculture, I think, a lot. We don't use furlongs a lot. Maybe, is that a horse racing term? Used a lot in horse racing, but we don't talk about them in normal everyday life, unless you're a farmer. but the others should be fairly familiar. I'm throwing in some unusual ones because we want to be able to use this process of conversion, regardless of whether the units are things that we're used to or not. All right, enough with that. We're going to talk about a couple different methods. This first one I'm going to go through fairly quickly because I want to get to the second method, which is what we're going to use more often. But this first method is useful if you're familiar with the units, I would say. And it boils down to multiplying or dividing by a known conversion factor or conversion amount. It's useful for a lot of on-the-job applications. So if you don't want to write down a lot of fractions or do a lot of mathematics on pencil and paper, this one can often be done quickly on the job. And as mentioned, it's used when simple unit conversions are made. Let's just stick with the feet and inches conversion factor. What if we wanted to express 76.53 inches as feet? Then we can note here that we are going from a smaller unit, inches. Yes, took me a minute there. I had to look at that. We're going from a smaller unit, inches, to a larger unit, feet. We know from experience that an inch is smaller than a foot. So we would expect our answer to be smaller. There should be fewer of the larger unit feet. Therefore, that 12, which is the number in the conversion factor, I am going to divide by. I'm going to take the 76.53 inches and I'm going to divide it by the 12 to get 6.3775 feet. So that's one you might be able to just look at and decide, okay, I need to divide. I know that much. And if you are able to do that quickly, that's totally fine. Let's maybe do one or two more like that. Let's express 2.28 yards in inches, and we're given that the conversion factor is 1 yard is equal to 36 inches. We are once again going from a larger unit to a smaller unit. Or excuse me, that's reverse. What am I saying? We are going, yes, from a larger unit to a smaller unit. Therefore, we expect there to be a larger number as a result. There are more inches than there are yards in that 2.28 yards quantity. Therefore, I'm going to multiply 2.28 times my conversion factor number is 36. So 2.28 times 36 is 82.08 inches. So there are 82.08 inches in 2.28 yards. See if I can get my words working here. Okay, similarly, if I'm given 2.25 feet or 21.25 feet, and I want to write it in yards, then I am going from a smaller unit to a larger unit. We know that because it will take 3 feet to make 1 yard. A foot is smaller than a yard. And therefore, I should get a number that is smaller than the 21.25 feet. So I'm going to take 21.25 and I'm going to divide it by that number that exists in the conversion factor. 21.25 is equal to, we don't get something exact, but it's 7.083. Your calculator will have this 3 repeating. So it'll be 7.08333333, etc. We're going to round that for most of the problems in this section. We can round to 2 decimal places. So I'm going to round to 7.08 yards. Okay. Questions on any of those? Are you feeling okay about that? Yes, Dennis.
My question would be, do we have to round it up in case, do we have to round it up like this?
Good question. So my number, if you put this in your calculator, you're gonna get 7.08333333, etc., etc., etc. Okay.
Okay,
If I want to round to 2 decimal places, then this is my second decimal place. If I want to determine whether to round up or round down, I'm going to look at this next decimal to the right. I can note that the 3 is smaller than 5.
right.
Smaller than 5. Therefore, I'm going to not round up. This
Okay,
will be 7.08. I'm not going to add 1 to the 8. I'm just going to leave it like that. If
got
it
it.
were 5 or bigger, I agree, I would round up. Does that make sense?
Yeah. Yes.
Okay, awesome. Other questions? All right, sounds good. Like I said, that is a method that you can use for some of the easier conversions. Sometimes they get more complicated than though, and so we want a different way of converting that will help us to keep track of our units, to keep track of whether to multiply or divide in a particular context. And this will also come up quite a bit in future lessons where we're expanding outside of distance or weight. And so it's a good method to learn. All right. Let's talk about method 2. And method 2 involves converting units using what is called a unity fraction, which I think someone asked about very first class. So here it is. We are going to talk about it. When we are converting units using a unity fraction, we can begin by looking at our conversion chart. For example, that conversion factor, that 12 inches, is equal to 1 foot. So using that conversion factor, we can form 2 different fractions. So we can make this a vertical conversion factor. Just as an aside, we call it the unity fraction because whenever we divide something by itself, we always get 1, which is the unit. It's the numerical version of a unit. And when we take 12 inches divided by 1 foot, we're dividing something by itself, essentially, 2 equal things. You don't need to know that part, but in case you're interested. We are going to use the unity fraction as follows. Before, I'm going to do this, sometimes it's easier just to see it written out. Before, if say we wanted to convert 76.53 inches to feet, we would note our conversion factor and decide whether to multiply or divide. To use this method of the unity fraction, we are going to, first of all, set up our starting unit as a fraction, which means I'm just going to put it over 1. Every number technically has a denominator of 1 if it is not written. So I'm going to go ahead and input that because we are dealing with fractions now. So it's helpful to convert everything to fractional form. I am now going to multiply by one of those unity fractions that I formed using the conversion factor. I'm going to multiply by the unity fraction that will cause this unit inches to cancel. Therefore, I'm going to use the form of the unity fraction that has inches on bottom, because if we happen to have the same factor in the numerator and the denominator of any fraction or any product of fractions, then those will cancel. So this inch unit will go away. If inches are on bottom of the unity fraction that I chose, that means feet must be on top. I put feet on top. And then I could find the unity fraction that corresponds to that. It's this one. I can input my numbers. 1 goes with the feet. 12 goes with the inches. Okay, great. And now, as noted, those inches will cancel because I have inches on top and inches on bottom. Same factor, top and bottom. All right. So we've determined which unity fraction to use. We've determined that the end result will have this unit of feet, which is what we want. The last thing we have to determine is, do we multiply or divide by this number 12? You can note that here the 12 is in the denominator of the unity fraction. So we are going to divide the 76.53 by 12. Dividing 76.53 by 12, we did earlier. It should be equal to about 6.3775, or exactly equal to, not about equal to. And then our feet is the unit remaining. And that's kind of explained up here. We chose our unity fraction appropriately. We did not want to choose the unity fraction with the inches on top, because then we would get inches times inches on top, not the unit that we want to end up with. We chose the unity fraction that caused the inches to be on top and bottom of the two different fractions, therefore they canceled. And then we decided that since the conversion factor has the number greater than 1 on bottom, we will divide. We're going to do this several times, so don't be worried if you can't follow just yet, but do you have any questions for me before we move to the next problem?
Why didn't we round it up to 6.3775?
The 6.3775. This one I actually didn't do on my calculator. Let's pull it up on the calculator and see what the calculator gives. Let's see. 76.53, divide that by 12, and we get exactly 6.3775. I chose to write that exactly and not round that. That's why it was 4 decimals. It looks
Copy.
like that's what I did. Good question. Other questions about that one? Okay. Let's do some more then. And for these, I'm going to go ahead and directly give you the conversion in here. It's just a little bit easier than pulling up the conversion chart. But we will be using that conversion chart eventually. So it's a good thing to have it with you. Let's express 2.45 miles as rods. First thing we want to do is on our conversion chart, we find how to relate miles and rods. So this is one of those odd ones that we don't use rods very often. Now that we've found it, we can make two different fractions, two different unity fractions. I could either choose to put the 1 mile on top or to put the 1 mile on bottom. Okay, we're going to use one of those, not both. I'm taking 2.45 miles. I'm going to write that starting value as a fraction. And then I want to multiply by the unity fraction that has miles in the denominator, because I want these miles in the numerator of my original amount to cancel with miles in the denominator of my unity fraction. If miles are on bottom of my unity fraction, that means rods are on top. So I'm going to choose to use that unity fraction that has rods on top, miles on bottom. I can input the numbers that correspond to each. Okay. So I have chosen my unity fraction. The only thing I still have to decide is whether to multiply by or divide by this 320. We can note that 320 is in the numerator, so I am going to multiply. Multiply 2.54 by 320. Let's bring in our calculator. What did we say? 2.54 or 45 times 320. I can write that exactly as a whole number, so I will do that. I'm not going to round for this one. 784. 784. And rods are the unit that did not cancel. They are my resulting unit that I always want to write if I'm doing a unit conversion. Okay. Maybe one more strange one. Let's convert 6.05 furlongs to miles. So again, this is one that you're probably not as familiar with, so it might be a little bit more difficult to determine, do I multiply or do I divide? So we're going to set this up using a unity fraction. Our conversion factor that we're given on that chart is 1 mile is equal to 8 furlongs. With that, we can make two different unity fractions. And we have to determine which of those we're going to use. So I'm going to start by writing my 6.05 furlongs as a fraction, which means I'm going to put the denominator as 1. And I'm going to choose to multiply in such a way that I have starting value of furlongs on top, which means I want to multiply by the unity fraction that has furlongs on bottom. That means I should have miles on top. So I'm going to choose my unity fraction that has miles on top, furlongs on bottom, write in the corresponding numbers that go with miles and furlongs. And now I can note that my furlongs will cancel. I have them on top and bottom. Finally, I can note that the 8 is in the denominator. Therefore, I'm going to divide 6.05 by 8 to get my solution. Let's do that. 6.05 divided by 8. I could round that to 2 decimals if I want to, but I don't really need to necessarily, so I'm going to go ahead and leave it as is, 0.75625. 0.75625. My unit that remains is miles. If you were to round to 2 decimal places, then you would get 0.76 or 1/6 of a mile. Read the instructions on your quiz. The instructions on your quiz will tell you whether to round or not. And you do want to pay attention to that. It might say to write the answer exactly, or it might say to round to 2 decimal places. Okay, we all right with that? Questions on that one? Okay, and again, we're going to continue working with the unity fractions for quite some time, working with this type of setup. So if it is not clicking now, hopefully it will as we continue to do some problems. For example, for the problem below, one way unity fractions are quite helpful is that they allow us to do multiple conversions a little bit more quickly. It's not always, we can't always do conversions as a one-step process. Sometimes we need more than one unit, unity fraction, more than one conversion factor to get from one unit to another. Unity fractions can make that process a little bit more straightforward. So let's do one of those problems now. We're asked to express 922 feet as furlongs. So back to furlongs. And normally we would look at our conversion chart and we would try to determine a conversion factor that has feet on one side and furlongs on another. Unfortunately, that conversion chart does not have a direct conversion between the two. If that happens to be the case, if you cannot find a direct relationship between the two units that you are wanting to convert between, in this case, feet and furlongs, you may have to use 2 different conversion factors, having an intermediate unit. So what we can find on that conversion chart is we know we could convert feet to yards by this conversion factor. 1 yard is equal to 3 feet. And we could convert yards to furlongs. So we could find a relationship between furlongs and yards. So here we would call yards our intermediate unit. Yards we might call the intermediate unit. Intermediate unit, because it is a connecting factor between feet and furlongs. We could also use miles as an intermediate unit. So you might see that if you're looking at the conversion chart, or use miles. So there's often more than one intermediate unit. You could use miles by noting that 1 mile is equal to 5,280 feet. And 1 mile is equal to 0.8 furlongs. So this is a way to connect feet and furlongs by that intermediate unit of a mile. So you can use either one here. I think I'm going to use yards as our intermediate unit, mostly because it's already written down, typed out on this PowerPoint, but you could use miles. Our process doesn't change though. We just have 2 different fractions to deal with. So we're going to, first of all, write that starting amount, 922 feet, as a fraction. So we're going to write it with a denominator of 1. Once we have written it as a fraction, I want to convert it to that intermediate unit. I'm going to go from feet to yards. So I think we can do that by noting, okay, if feet are in the numerator here, I want feet to be in the denominator of my unity fraction, which means I have yards in the numerator. This is the unity fraction. with feet in the denominator, yards in the numerator. So I'm going to fill in the numbers that go with each of those units. So we have converted from feet to yards. I'm not going to multiply yet. I'm going to choose to multiply all in one step at the end. But we can note here that the unit that I'm now working with is yards. Now that I've converted from feet to yards, I can go from yards to furlongs. I'm going to multiply by some unity fraction that, okay, we have yards on top here. So I want to multiply by a unity fraction that has yards on bottom now. But I don't want yards in my final answer. I want that to cancel, which means I want furlongs on top. That allows yards to be on top and on bottom. And so the unit that remains here is furlongs. It looks like I have a unity fraction here that has yards on bottom, furlongs on top. So I'll put the 1 here, put the 220 here. All right. So we have our unity fractions set up. We have obtained furlongs as the one remaining unit. The only thing left to do is to determine, do I multiply or do I divide by those two numbers? We have to make a different decision for each because it won't always be the same for more than one unity fraction. The 3 I'm going to divide by because it's in the denominator. The 220 also happens to be in the denominator, so I'm going to divide by the 220. My calculator can handle this all in one step. So let's jump into that. I'm going to take 922, divide that by 3, divide that by 220, and we get 1.3969696, etc., etc. This is one that we have to round or write with a bar on top. So I'm going to round to 2 decimal places. The 9 is in the second decimal place. So if I look to the right, that's a 6. That is bigger than 5. So that will cause the 9 to increase to a 10, which will be 1.4 is my rounded solution. 1.40 or just 1.4 if you prefer. And furlongs is my unit. Okay, questions on that? Okay. So there's an example with 2 different unity fractions. As long as no one has questions, let's change things up a little bit. Let's bring back the metric system. Because as mentioned, we can convert between systems. We don't have to just stay within one system or the other. Your conversion chart does have a box that has the metric to customary length conversions. Max, are you talking about assigning problems as in having you work through some in and answer questions in the chat? Yes, I can do that. We will get to that in just a moment. Great question. But let's do one example or two examples, I guess, using conversions between the metric and customary systems. We're going to use unity fractions again. If anytime that we have something set up like this, where I know how many of one unit is equal to how many of another unit, I can use that unity fraction method. There we go, words, to convert between the two. So let's do an example here. Let's express 33.1 yards as meters. So let's do that here. I'm going to, as mentioned, write 33.1 yards as a fraction. So I'm going to begin there. I want to find a relationship on our conversion chart between yards and meters. Looks like we have one right here. That is my conversion factor. You have up till now just been given the conversion factors, but you'll need to be able to start finding them on the conversion chart. So that is my conversion factor. I want to multiply by a unity fraction. And my unity fraction, I want yards on bottom because the unit that I start with has yards on top, and I want those yards to cancel. If yards are on bottom, that means I have meters on top. It looks like with this conversion factor, the number that goes with meters is 0.9144. So I'm going to put that next to meters, and the number that goes with yards is 1. So I want to put the numbers with the units that they are assigned to according to my conversion factor. This causes yards to cancel. So I have yards on top and yards on bottom. And I can note, just like before, that if this number not equal to 1 is on top, I'm going to multiply. Multiply 33.1 by 0.9144. Let's go ahead and do that. 33.1 times 0.9144. Make sure I got that correct. Yep. That is equal to 30.26664. Again, we could, I didn't do a great job with saying whether to round or not on this handout, but we could write this exactly, but I think I'm going to round to 2 decimals as 30.27. So that is equal to 30.27, and the unit that remains is meters. So that is the unit of the 30.27. Okay, questions on that? We won't get super tricky here, just trying to get used to setting things up using the unity fraction. I'll do one more, and then I'll let you do the second one. Will I? No, I'll do the second one, and I'll let you do the first one. How's that? Because the second one has a little bit of review. So if I wanted to convert 10.4 centimeters to the nearest 64th of an inch, then I'm going to start by writing my 10.4 centimeters as a fraction, put it over 1. I can go up to my conversion chart and I can find a conversion between inches and centimeters. Looks like that top one is a conversion between inches and centimeters. 1 inch is equal to 2.54 centimeters. So maybe I'll go ahead and write that down here. 1 inch is equal to 2.54 centimeters. There we go. So first step, I want to convert this to inches. So I'm going to choose to multiply by the unity fraction that has centimeters on bottom because I want the centimeters on top to cancel. That means that inches needs to be on top. 2.54 is the number next to centimeters. So that's what goes next to centimeters in my unity fraction. 1 is the number next to inches. So that's what goes next to inches in my unity fraction. 2.54 is now in the denominator. So that means I want to divide 10.4 by 2.54. My centimeters will cancel. That will give me the solution in decimal form in inches. Let's bring up our calculator. 10.4, oops, need a decimal point in there, divided by 2.54 is equal to something that is exciting. 4.0945 inches, approximately. So I'm not going to take that number out of my calculator yet. 4.094, etc. inches. All right. So we have this this number now in inches, but we want to go a little bit further. We want to convert it to the nearest 64th of an inch. That was something we did on the very first day of class. So we know this is going to be 4 and some 64ths of an inch. I want to figure out how many 64ths is it. To do that, I'm going to take this decimal portion of my solution. I'm going to multiply it by 64. And that'll give me the number of 64ths of an inch. That's why I didn't take this out of my calculator. Let's go ahead and go back to our calculator. So I want to take those digits to the right of the decimal point, and I want to multiply those by 64. If I don't want to do extra calculations here, I could just take away that 4, and then that gives me the digits to the right of the decimal point. I'm going to choose to multiply that by 64. And that gives me 6.04 something, something, something. Okay, so that is the number of 64ths of an inch. So it's 6.04, etc., etc. At this point, I can round. I want to round the numerator to the nearest whole number, which is 6. So it's 4 and 6 64ths. Last step we need. I want to divide the top and the bottom by 2 of that fraction, giving me 4 and 3/32 of an inch. So we have converted 10.4 centimeters to the nearest 64th of an inch, using a unity fraction and stuff that we talked about first class. Questions about that one before I let you do a problem? Okay, great. Why don't you, if you do have one, feel free to put it in the chat. Why don't you try this one? Take a couple of minutes, convert 72.5 miles to kilometers. And I will go ahead and pull it almost all the way to the top, because that will give you the conversion factor between miles and kilometers up there. Take a couple minutes to do that. See if you can put it in the chat. And yeah, you do want to round to 2 decimal places. Okay, great. Okay, good. I like it that you're putting units in there, since we're talking specifically about units. Include units in your solution. Okay, great. Yeah, good. All right, y'all are fast. Let's work through this briefly. 72.5 miles. Write that as a fraction. I want to multiply by a unity fraction that has miles on bottom, kilometers on top. I can look up at that conversion factor. It looks like 1 is the number next to miles, 1.6093 is the number next to kilometers. So I'm going to input those. And then 1 goes next to miles. So those miles will cancel since I have miles on top and miles on bottom, meaning that kilometers is the unit that we end up with. And then it looks like you all were multiplying, which I agree. We're going to multiply by 1.6093. And let's see, what do you get? I had one question about rounding, so let's go ahead and do that in the calculator. 72.5 times 1.6093. You get 116.67. And because that 4 right next to the decimal point is, right to the right of the 7, excuse me, is smaller than 5, we're going to leave the 7 as is. We're not going to round it up to 8. So it should be 116.67, and our unit is kilometers. Perfect. Okay, we feeling good about that? Okay. Looks to me as if you are by your answers. So that's good to know. How about an application? And this one isn't too bad. A welding electrode is 1/8 of an inch. This is a pretty straightforward conversion problem. We want to convert this electrode to millimeters, excuse me. One thing that I am going to do to begin this, though, is I'm going to make this a little bit easier on myself. I'm going to convert the 1/8 to decimal form. Let's convert 1/8 to decimal form, and we can do that by dividing the top by the bottom. Grab our calculator, take the top 1, divide it by the bottom 8, and we get 0.125. Sometimes we can get in trouble by converting a fraction to a decimal because we'll have to round. But in this case, I can write it exactly. I don't have a series of non-repeating decimals to deal with. I just have 3. So this one I can safely do in decimal form. So that's equal to 0.125. There we go. Okay. You might, depending on which industry you're working in, you might already know the inches to millimeters conversion factor. But we're not going to do this in one step. We don't necessarily have a conversion factor that is directly relating inches and millimeters. So if we use what's on that conversion chart on Canvas, we have to use two different conversion factors, or use one conversion factor and then use what we talked about last time with prefixes. I think let's do the latter. We want to go from inches to millimeters. We don't have a direct conversion factor for that, but we do have a conversion factor from inches to centimeters, and we do know how to get from centimeters to millimeters. So that's the path that we're going to go on this one. Let's go from inches to centimeters, and then let's go from centimeters to millimeters. So I'm going to go from 0.125 inches, put that over 1. I can note in my conversion chart above, I should just grab that conversion chart, that I have one conversion factor here from inches to centimeters. We already used it once, we'll use it a second time. Okay. This tells us 1 inch is equal to 2.54 centimeters. So if I want to convert from inches to centimeters, I'm going to make a unity fraction that has inches on bottom, which means my centimeters goes on top. This is from inches to centimeters. I have to put the number that goes with inches, 1 by that inches unit, and then 2.54 by that centimeters unit using that conversion factor. All right. And now I can note that 2.54 is in the numerator, so I'm going to multiply in order to get that unit of centimeters, which remains 0.125 times 2.54. Bring up our calculator. Oops, I needed that. 0.125 times 2.54 gives us 0.3175. And note, we're in the middle of the problem. Even if I want to round at some point, I am not going to round now. I'm going to wait until the end of my problem to think about any type of rounding. So I'm going to use that whole number, 0.3175. So this is if my paper will work, 0.3175, and that is in centimeters. Great. So we got there, got halfway there. We now want to convert our centimeters to millimeters. So we have 0.3175 centimeters. To convert from centimeters to millimeters, this is a metric to metric conversion. Therefore, I can remember my prefixes. King Henry died unusually drinking chocolate milk. And I can decide how many decimal places I want to move. We start with centimeters, which is here. And we move just one space to the right to millimeters. So we're going to go 1 right. So in my centimeters above, I'm just going to go 1 to the right there, which means my final answer is 3.175 millimeters. If you want to write it exactly, or if your problem in Canvas happens to ask you to round, you would round to 3.18 millimeters if it asks you to round to the nearest hundredth of an millimeter, or to 2 decimal places. So we can, at times, mix what we talked about last time with the unity fractions as well. Questions on that? Feeling good? All right. Let's do another application. Because why not? So let's solve the following word problems involving conversions. And look at that. There is a specification on rounding. Round to 2 decimal places where necessary. Great. Got it in the last couple problems at least. Or the last problem, I should say. No, we have more beyond this. Ooh, I need to hurry. So this application says that a 4-meter length of wire is cut into 72 equally sized pieces. What is the length of each piece in inches, rounded to the nearest 64th of an inch? And the last problem that we did assumed some waste. We are not assuming any waste in cutting this time. All right. And we've talked about the things that we need to keep in mind when we're working word problems like this are what type of operations do we need to do? Are we adding, subtracting, multiplying, or dividing, or maybe a combination of those? And then second, do we need to do any unit conversions? Now that we're talking about unit conversions, we have to think about the units that we're working with. I like a picture. I don't know if you're a picture person, but I like to draw a picture. It is 4 meters in length, this particular piece of wire. And we are told that we are cutting this into 72 equal size pieces. So I'm not going to draw 72 little marks. But I can at least do that to get an idea of what's happening. Let's first of all do this. Let's figure out what operations are needed. What mathematical operation do you suppose we would use here? We would use multiplication, division, addition, or subtraction to answer the question, what is the length of each piece?
Division.
Yeah, I would agree. I think we would use division. I think we would take the 4 meters, the length, divide that into 72 pieces. Okay, that's pretty doable. Pull up our calculator. 4 meters, divide that into 72 pieces. We get 0.05 repeating. So we are in the middle of the problem. I don't want to round at this point. So I'm just going to leave that number in my calculator. Just so I have something written down. This is 0.05 repeating. And I have to note that my unit is in meters. I'll go ahead and write that down. I don't want to lose my units because I'm dealing with multiple types of units. Okay. So we got that part, got the operations. I now want to convert because we are asked to write our answer to the nearest 64th of an inch. So we want to convert meters to inches now. Once again, looking at our chart, there is not a direct conversion between meters and inches. There are 2 different ways that we could find an intermediate unit. We could go from meters to centimeters to inches, or we could go from meters to yards to inches. Those are both paths that we could take. I think I'm gonna do this latter one, because that'll allow me to just do 3 different unity fractions. Or excuse me, 2 different unity fractions, and I can do my multiplication all at once. So if we look at our conversion chart, go all the way up to here, we can note that there is a conversion between yards and meters, which we've used before. 1 yard is equal to 0.9144 meters. So we're going to use that down below, all the way down. So 1 yard. Let's see if I can get my right pen here. 1 yard is equal to 0.9144 meters. And then I won't go up, but you could also note above that 1 yard is also equal to 36 inches. That's a conversion factor that you could find. So I am going to take my 0.05 repeating meters, create a fraction with that, and I am going to convert that to yards, my intermediate unit, first of all. So I'm going to multiply by something that has meters on bottom, yards on top, put my numbers with that. So I have 0.9144 and then 1 yard on top. So my meters have canceled. Okay. I now have my unit in yards, so I want to convert that now to inches. I can do that using another unity fraction. I'm going to multiply by something that now has yards on bottom because I had yards on top on the one on the left. That means I need inches on top. Put the numbers that go with yards and inches in. 1 yard, 36 inches. Yards on top, yards on bottom cancel. The unit that remains is inches, which is what we want. Okay. And now I have to think about my operations again. It looks like the 0.9144 is in the denominator, so I want to divide by that 0.9144. The 36, however, is in the numerator. So this is a case where I do 2 different operations. I'm going to multiply by the 36. So I'm going to take the number that's in my calculator, divide by 0.9144, and multiply by 36. So let's do that. This number is still in my calculator. I'm going to divide that by 0.9144. 144. So that's equal to that. And then I'm going to multiply by 36. And I get 21.18722 something something or other. Okay. So that is the number of inches of each piece. We're not quite done yet though, because we need to convert this to the nearest 64th of an inch, which I'm looking at the time and I'm going to do kind of quickly here. So I apologize. It's about 2.1872 something. I'm going to take this decimal. I'm going to note that this will be 2 and some 64ths of an inch. I want to take that decimal, multiply it by 64. So back to our calculator. I'm going to take away the 2 here. That gives me that decimal. Multiply that by 64. And I get 11.9825 something. So it's got 11.98 something. That I don't want to leave as a decimal. I'll round it to the nearest whole number. So that's 2 and 12/64. I can reduce that now. Divide the top and the bottom by 4. And I get 2 and 3/16. And I need to make sure that I put my units in there. because this lesson is all about units, so I can't forget those. Okay. We have about 5 minutes. I do want to get to this next couple of slides. So happy to answer questions at the end, but right now I think I'm going to move on to these. Everything that we've talked about so far has been linear, a linear unit, so distance. But we can do something similar with weight. Little bit of a distinction here. I should give some definitions. Weight measures the force of gravity on an object. Mass measures the amount of matter in the object. It seems like a change, but it's really not. We measure on Earth mass by its weight. So units of weight and mass we can use interchangeably here. And we can use that same process of unity fractions to convert between units of weight and mass. You will see on your conversion chart, oddly enough, 2 more tables that involve units of weight in both the metric system and the customary system. So here on the left, we have the customary system units of weight. Here on the right, we have the metric to customary system units of weight. So same process as before, we're just talking about a different type of unit. For example, if we want to express 0.65 pounds as grams, then we're going to take 0.65 pounds, make that a fraction. We can find above that there is not a direct correlation between pounds and grams. So I need to find an intermediate unit. I do have a relation between pounds and ounces here, and then I have a relation between ounces and grams. So it looks like ounces could be our intermediate unit. So I could go from pounds to ounces to grams, and that'll work out just fine. So I'm going to multiply here, convert pounds to ounces first of all. So I'm going to use the unit that has pounds on top, ounces on bottom. It looks like the conversion factor on the left puts 16 by my number of ounces and 1 by pounds. That's great. Pounds cancel. So that gets me to ounces. And now I want to go from ounces to grams. That is the right-hand conversion factor. I'll put ounces on bottom here. I will put grams on top. All right. And it looks like that conversion factor has 28.35 grams here, 1 ounce on top. We are going to multiply by both 0.65 times 16 times 28.35. I won't show this calculation, but it is 294.84 grams, because grams is the unit that remains. My ounces have canceled. Okay. There were other factors that we could have used to get that same conversion, but that was the path I chose. I think we can do one more slide, and then we will do the next example at the beginning of class next time. I want you to have this before your quiz. So let's say we have 250 identical strips sheared from a sheet of steel that weighs 42.25 pounds. We want to find the weight in ounces of each strip. Couple things to note here. I'm given a number. We want 250 strips. Given a weight in pounds, I want to find the weight in ounces. So we have the strip weighing 42.25 pounds, and it's being divided into 250 identical strips. And I want my final weight in ounces. Maybe let's start by converting to ounces. 42.25 pounds over 1. I can get from my conversion chart, 16 ounces is equal to 1 pound. So I'll put pounds on bottom here, ounces on top, 16 and 1. I will multiply and get 676 ounces. Great. That's the weight of the whole thing. Then I'm going to take my 676 ounces. And since I'm dividing it into strips, I'm going to divide that by 250, which gives me 2.704 ounces. Or if we want to round to 2 decimal places as necessary, 2.70 ounces, or just 2.7. So there's another nice application. And I think we are out of time, so we will do the last example beginning of class next time. It doesn't show up on your quiz, so I'm not as worried about it, but I do want to do it. Any questions you all have before you leave?
Will this last question show up on the quiz, on quiz 2?
This one, something like this, possibly. I don't remember if that one exactly does, but I know the last one doesn't. The last one that we didn't cover doesn't.
So this would be for quiz 2 or 3?
Quiz 3, because this is lesson 3.
Okay.
You have to put that 0 there for the answer to be correct.
Good question. You don't necessarily have to put the 0, no. I just put it there to emphasize that we did in fact round to 2 decimal places and not 1. But your Canvas quizzes will count it correct regardless of whether you put the 0. Christian, I can't answer that question for test yet. Quiz or Max, excuse me. Quiz, that last question on this that we haven't gone over won't be on here, but test, I can't answer that question yet.
Because on that quiz 2, on the 6th problem, the first attempt I did, the answer was 0.60. And I thought I hit the 0.60, like 0.60, but I guess I didn't get the 0 in there, and it counted me wrong. So I'd take it again. And then the quiz is different on the 2nd attempt.
Right.
And number 6 is, well, and it's a different quiz, and I did the math wrong on the 2nd attempt, so it took me 3 times to get that right. But
let me look at it.
when I went down and it showed correct, and I got the last one on my first attempt, it showed 0.6 and it counted me wrong. Which I'm fine with that. It's not a big deal, but that's why I asked you on this one.
Totally. I think for that one, at least for your first attempt, I would look back and make sure that you're not rounding in the middle. Because I think maybe there was a rounding error elsewhere.
Well, I did it all on paper. And the answer on that one was 0.595.
Yeah, I would go back and look at your rounding on that one. So we can.
Because it shows the correct answer whenever you see what your results are.
Mhm.
and it showed I put in 0.6, which I didn't mean to do it that way. I had a cat crawling up in my lap, and I guess I didn't have it in the last zero in there. But anyway, and then below it, it showed the correct answer was 0.0 or 0.60.
Okay.
I think that's what it said.
Mm-hmm. I am looking at, and this could apply to others. Thank you all. You're free to go if you want, but feel free to ask questions as well. I'm looking at your work and I'm not seeing the 0.60 as a possible answer. I would have to see your work itself to really be able to, say. But I'm thinking that maybe there was an earlier rounding that you did that caused the final answer to be off.
It was convert 35 milliliters to liters. And so I went 3 spaces over and it became 0.035 liters.
Okay.
And multiply it by 17 samples for each bottle, which was 0.595 liters. Is that not right?
Let's see. So you converted 35 milliliters
To liters.
to liters. Okay. And what'd you get?
And it's 0.035.
Okay. Great. Liters.
And then I multiplied it by 17 samples for each bottle.
All right. So let's see. 0.35. Pull up this. Did you factor in the 1.12?
I did it on a scratch pad and I think I threw it away. It's 1.12 minus 0.5. Well, if you're, I don't know, you're not supposed to round it until you get to the final.
You're not supposed to round it till you get to the final, correct?
I mean, maybe that's. Do you not see my first attempt? You only see the one that actually.
No, I can see your first one.
Okay, so 0.595. Well, actually, it's 1.12. I'm doing it backwards. My bad. 1.12 minus 0.5. Oh, why did, maybe I was just tired and I read it wrong, because I'm getting 0.525.
And that sounds more like it.
And that would be a liter. Or if you,
Mhm.
and I think you're supposed to round it, so it would have been 5.3.
Yeah, and I think that sounds more like it.
So I did get that one wrong, and I did the same thing on the second attempt. I got that same number 6 wrong. And I know what I did wrong on it though, but mistakes are good because you learn from your mistakes, because
Exactly.
yeah, because I did, on the second attempt, I know what I did wrong.
Okay.
I didn't multiply the 7mm waste out for each cut. I only did it with the 7mm one time. I know
Okay.
what that's what I did, and it was supposed to be 3 cuts. So I should have done like, what did that be, 21 millimeters instead, and so I had the math wrong on that part. But yeah, okay. So that
Okay.
was just asking if the
Gotcha.
0 makes a difference. That was my original question.
Yeah, the 0 shouldn't make a difference on that.
Unless it, so if the instructions say round to the nearest 2 digits,
Mm-hmm.
then you
And-
should have 2 digits there, even if it's a 0.
Canvas should take it, even if the last, if the last digit is a 0, Canvas still should accept it if you don't include the 0. If the last digit is anything other than a 0, make sure you put that digit in.
And if we put the 0 in it, it
Then
should
it'll
make it
accept
that
that
way
too.
too.
Yeah, it'll accept it.
Okay. Trying to get used to this chart, because some of the stuff we were doing in class today, it's like, what chart is she looking at? Because you have customary and then you have
Mhm,
all this other, and so you just gotta get familiar with that page. I
exactly.
have a copy of it in front of me, but I'm just like, where's she seeing that?
Mhm.
But yeah, I'll figure it out. All right.
And we're gonna use that same chart a lot, so you'll get used to where things are, and in future classes, I'll be bringing it up instead of inputting it into my slides. This one, I didn't get around to that.
Okay,
All
all right.
right,
Thank you.
you're welcome. Have a good day.
Uh-huh.